So in this case, there's a typographical error, the A, then that sign, then plus, then question mark supposed to be an arrow. So magnesium solid, then 2 moles of hydrochloric acid aqueous, then should be resulting arrow of the chemical reaction, magnesium chloride aqueous plus hydrogen gas, that is diatomic hydrogen gas. So that is the chemical equation for the reaction. So from the equation above, the mass of magnesium required to react with 250 centimeter cube of 0.5 HCl, that is molar concentration of HCl. So if you remember formulas, then we have the relative atomic mass in brackets giving magnesium is equals to 24. All of these things are needed, but what we need to find is the mass of magnesium. We have to find the mass of magnesium, but we are given the concentration and the volume, the molar concentration 0.5 and the volume 250 centimeter cube. So just take note of that. So before then, let's recap some formulas. The number of moles is actually equals to the molar concentration times the volume, but the volume should be in dm cube. Decimeter is 10, 10, 10, that's 1000. So if it relates to centimeter, you divide by 1000. So then the number of moles is equals to m, which is mass, the mass reacted over the molar mass. So if you do the surrogate of the formula, the molar mass, which is the capital M, is equals to mass in gram over the number of moles. So these are the formulas. Also, therefore, the mass in gram is also equals to the n number of molecules, number of moles times the capital M molar mass. Then also, now in case vapor density is involved, the molar mass is equals to 2 times the vapor density. So let's solve. You can refer back to that formula whereby I said the number of moles equals to the concentration times the volume, but the volume is represented in dm cube, so the concentration, so if you remember, it is Na. This HCl is an acid, so if you want to get the number of moles but you are just giving the concentration and the volume, so you are going to use that Na equals to CaVa. So we are going to draw a table, mass, then HCl. We draw the table. Now we'll follow everything that is given as the standard from the chemical equation of the reaction. Mg, then 2HCl, then Mg chloride, magnesium chloride, then the atomic hydrogen gas. So the first is the mass relating to the mole. So the mole of magnesium, they are just invisible 1, so there should be the 1. So the mass of magnesium, the general mass, relative atomic mass is 24, so it's balanced. So the next one is 2. We are going to base on HCl. HCl here is 2 moles. So the 2 moles, HCl is actually 35.36, I think so, 0.5. If you calculate, H is 1, chlorine is 35.5. 1 plus 35.5 is 36.5. But because it's doubled, which is carrying 2 moles, 2 HCl, the standard becomes 73 gram totally. So the relative molecular mass or relative atomic mass for just one element, then molecular mass for all the elements there. So those are the standard. So this method is actually quite different and easy. So we have to get the mass of magnesium in the other way. So the standard is giving 1 mass for magnesium, 24 gram for magnesium, 2 moles for HCl, 73 gram for HCl. Now we need to get the moles. We need to get something for the other one below. Now what is reacting is 250 centimeter of 0.5. So to get the number of moles according to the formula, Na equals to CaVa. So once you multiply, you represent centimeter in dm cube. To represent centimeter in dm cube, you have to divide by 1000. So once you multiply, the answer will be 0.125. So now that we have gotten that, our new table will be the one below. So it relates to the moles. So we'll put that 0.15 under the mole part, but this one is the second one, the one that is being reacted now. That we have found the mole to be 0.125, we apply it on the table. So you can use any part, but make sure that one part is given. So we are going to use 24 and 2. Then the question mark becomes Y, because we are looking for the gram, the new gram of magnesium according to this table. So the new gram of magnesium will relate to 0.125. You must pick one from the first part relating to the one below, the second from another part, any other part, even if they are from the same right side or left side, to give you the same answer. So we relate them, we bring them out, then we solve it. We just cross multiply, you can see what's happening, then you get your answer. So that's how we got the gram, and we have finally found the answer. But let me just give you the proof that we can also use this table to solve the rest of it. So we are going to find something else. So the answer is actually 1.5 gram, the new magnesium gram that reacts. So we have gotten it from the table. So we are going to find something more. So let's keep on. So let's just imagine now we were asked to find the mole, the new mole of magnesium. Normally it is one mole that reacts, but let's see the mole that will react according to the parameter given below. So we can take 124x and 1.5, or we can take 12x and 0.15. You must just make sure that only one part of the grid, first, second above, first, second below, is missing. Only one part. So you see the way it is solved. So this proves that we can take any part. I took 124x and 1.5 cross multiply. Then I took 12x and 0.15 cross multiply. If you go back to the table, refer to it, then you see it's the same. So if you solve, I like solving it in a long process. You could easily use your calculator. You'll find out that we got the same amount of moles. So it makes sense, because if the actual gram was 24 at that point and the mole was 1, so if the gram reduced, therefore the mole should even be more reduced. The new gram we got, I think, is 1.5. So therefore the corresponding moles should be that. So I think you should solve for y. If you solve for y, you can use any part of the grid, then you can write your answer in the comments.